to everyone who's joined on the webinar today. My name is Steve Gallo. I'm the Technical Operations Manager at AIBS at the SPARS Division, the Scientific Peer Advisory and Review Services Division. AIBS has been conducting external independent peer review services for a wide variety of funding agencies and research institutes for over 50 years. And in that time, we've generated a fair amount of data, and as of late have spent considerable effort trying to analyze that data and contribute to the currently pretty small body of knowledge and body of literature that exists about the peer review of research applications. The hope here is that it will not only help to improve our own processes, but to promote the general integrity of peer review in general. So that's a little bit of our backstory in terms of why we're interested in peer review. I'm joined today by Dr. Carole Lee from the University of Washington at Seattle in the Department of Philosophy.
You are in the Zoom meeting now. There are participants.
Sorry, can someone mute that? That'd be great. And so Dr. Lee is, her area of expertise is in the evaluation of knowledge with a focus on peer review. And so she's actually recently written an excellent literature review on the presence of bias in peer review. So she'll be joining us today. I'll be, sorry, one second, there we go. This webinar will be separated into two halves, as Diane kind of alluded to. The first will focus on some recent published work by AIBS analyzing conflict of interest data from a peer review of research applications to kind of get a sense of what the frequency of occurrence of conflicts of interest are in the peer review process. And then Dr. Lee is going to speak a little bit more generally in terms of bias in peer review and how reviewer bias can potentially undermine the goals of peer review. So, and again, because we're trying to squeeze a lot of information into a relatively small period of time, my apologies in advance if there are some questions that we don't get to during the Q&A sessions. There probably will be not horribly long. So if there are some questions that went unanswered, please feel free to email me or Dr. Lee. I think our email addresses will be at the end of each slide. And I can email them out to the group if necessary too. Okay, so a key component to the legitimacy of peer review is the perception that it is fair and equitable. And most peer review processes at funding agencies include a conflict of interest detection and removal process, removing reviewers from reviewing applications that they're in conflict with. And this is a process that's there to help maintain this equity of the peer review process. But unfortunately, not a lot of data is out there in terms of describing the frequency and types of conflicts of interest that exist in the peer review of research funding applications. Nevertheless, recent surveys have indicated that both research grant reviewers and applicants have ascribed a high level of importance to detecting and preventing non-financial conflicts of interest in peer review. What data is out there is largely focused on regulatory reviews. Specifically, there was a paper by Dr. Pham Kanter from Drexel University who focused on committee meetings at the FDA and largely focused on financial conflicts of interest. But nevertheless, that paper specifically tried to, one of the outputs was to quantify the frequency of conflicts of interest. But as far as we know, no studies on basic research exist. So in an effort to fill that gap, AIBS has conducted an analysis of some of our peer-reviewed data, which we recently published in the Journal of Science and Engineering Ethics in February. And I should mention this is one of the few publications that's not open access currently, but it's behind a paywall. But I think in February we're allowed to place the PDF up on our website. So I'll be sure to email the group to let you know when that's available. In terms of this particular biomedical research funding program, these are basic, relatively basic research awards. They're 2 to 3 year awards ranging from 300 to 900K. 275 applications were reviewed on 8 on-site ad hoc panels with an average of 12 panel members per panel and 35 applications per panel. So the way conflict of interest was essentially handled, or at least detected, really comes down to kind of three mechanisms. The first is when AIBS goes through its initial recruitment, there's a list that's generated once the proposals have been submitted of application personnel, and we use that list as a do not recruit list, essentially. And so probably the first step of avoiding a lot of conflicts of interest is simply just in the recruitment of the reviewers and avoiding those who have a direct conflict of interest. So that's probably the first step. The second is once reviewers are tentatively assigned to a panel, they're given access to an online contract, which allows them to first fill out a confidentiality agreement. And once they filled out that, they gain access to proposal titles and personnel information, including institutions of the personnel, on an online given online access to this. And they can click on individual proposals and see those personnel, and then if they have a conflict, they can mark a conflict, and there's a space where they have to identify what type of conflict or what are the details regarding that conflict. So this is a self-report by reviewers. Concomitantly with that, AIBS staff manually cross-check the reviewers' CVs with application documents in a structured searching procedure to look for potential conflicts. And so both of these are happening before reviewers are, formally assigned to a panel and assigned proposals. So these are our two major sources of data: the self-reported data and the staff-detected data. Again, the reviewers are given conflict of interest policies and definitions, as well as the conflict of interest criteria that they're used to judge whether they have a COI. And these are the same criteria used as many funding agencies, are very similar to the ones used by many funding agencies. And they encompass organizational affiliations, collaborations, financial interests, sources of research support, government service, public statements and positions, and then kind of a catch-all category of additional information. Things that tend to get caught in the catch-all tend to be things like my mother is the PI or something like that. So here's an actual shot of the output of this analysis, which at first just breaks down the frequency in terms of type of the different types of conflicts that are detected both through self-reported and staff-detected. And as you can see, over 65% of conflicts that were identified through manual AIBS detection. The majority of things that were caught by administratively. Of the things that were identified, they were overwhelmingly organizational or collaborative. There were no financial conflicts of interest identified in either mechanism. This is not completely surprising given the fact that, at least for staff detection of conflicts of interest, because financial information typically isn't included on a standard CV, there's nothing really to check, so it's difficult to actually cross-check for financial conflicts. Overall, 80% of the applications had no conflict, so they're relatively rare, although 20% of applications, an average of 7 to 35 per panel, had an identified conflict. That said, a significant proportion of reviewers per panel, roughly 39%, or 5 out of 12, were conflicted on at least one application. Multiplicity of conflicts were relatively rare, so most reviewers who had a conflict only had one conflict. So this gives you a sense and an appreciation for the fact that conflicts of interest do exist in a reasonable frequency, and that this kind of justifies having a COI procedure, is that they happen with at least somewhat regularity. So to compare this kind of frequency data, as I mentioned, the only data out there is this Pham-Cantor study, who they measured the level of conflict through a measure of conflictedness, I guess is what they call it. Our measure of conflictedness, which is not exactly the same, but it's similar, is measured as the proportion of reviewers conflicted for any one application, averaged across all applications per panel. So This ranged from about 1 to 4%, depending on the panel, with an average of about 2% across panels. And this was significantly lower than the 13% reported for regulatory reviews. So the first thought is, of course, well, probably there's less financial interconnectedness between basic researchers and applicants than there are for regulatory reviewers. And that may make sense because regulatory reviewers probably have more connectedness in terms of consulting with industry and things like this. But this is a bit of an apples and oranges comparison. Again, these are committee meetings for the FDA versus proposals. So we're looking at the same committee meeting multiple times over meeting about specific products, compared to a panel reviewing multiple proposals in the same kind of short 2-day time period. In addition, regulatory conflicts were predominantly financial, while we didn't detect any financial conflicts. And because there was underreporting, a fairly significant, substantial amount of underreporting, and due to the fact that the financial information isn't really present on most CVs, it's very well that we don't have an accurate read here of the number of financial conflicts of interest that exist. But and so this is definitely an area that needs to be explored. And again, while we feel that financial interconnectedness between applicants and reviewers varies probably quite a lot between basic and clinical, translational, product-driven types of research domains, there may be other factors that need to be explored. But that said, a significant proportion of reviewers had at least one conflict of interest per panel, suggesting that the COI procedures and identification are important. However, the majority of the conflicts were found through staff detection, so this underscores the need for administrative vigilance in detecting a lot of these conflicts. And while we can't discern the root causes of this underreporting through this current study, it certainly is an area that future studies should be focused on. For instance, we don't know if there's just a general lack of awareness of what truly is a conflict of interest, or an underappreciation for how other people could perceive something as a conflict, versus purposeful underreporting, which personally I find is probably less likely, but nevertheless it could happen. And again, we don't have, given this kind of case study, we don't really have the ability to discern what the root causes. So that certainly should be an area of future study. In addition, it may be that reviewer training may help in this regard to help reviewers understand what potential perceived conflicts of interests would be. Perhaps they're under-evaluating them, at least in terms of the potential impact and whether they're really a conflict of interest. There are some gray areas here, of course, so that also is something that ought to be included in reviewer training. And kind of a standardization of COI reporting, which I believe NIH is actually actively trying to work towards. In terms of future work that should be done in this area, certainly there should be more reporting on the frequency and type of conflicts that occur in basic peer review panels, using consistent measures so we can really get a sense of how often do these things come up and what types. And in addition to that, potentially coming up with ways to measure indirect financial conflicts of interest that may not be reported otherwise. And certainly examining the root causes of underreporting and whether using reviewer training can prospectively help improve reporting of conflicts of interest. And finally, exploring the prevalence of biases. And Dr. Lee's going to speak about this in a minute, but looking at these types of biases that are not caught by conflict of interest checking, and what potential impact they may have on decision-making processes. And the next slide is kind of just some preliminary data we have to show you an example of a potential bias that reviewers may not be even aware that they have, which is if reviewers are asked to self-assess their expertise relative to the proposal they're reviewing on a scale of 1 to 5, or 1 is the highest expertise and 5 is the lowest, and then they're also asked to rate the proposal on a scale of 1 to 5, where 1 is the best, it's found that reviewers that have a higher expertise sometimes can be a little harsher in terms of their grading. So this is an actual direct impact of potential bias related to reviewers' properties in terms of expertise that could have a direct impact on the decision-making processes and how proposals are ranked. So certainly these types of research results should inform future policies and procedures as to how conflict of interests should be assessed. And also if training can help to prevent some of these biases from occurring. And so I think that's it. I kind of flew through this a little bit because, again, we're trying to get through quite a lot. So I think at this point, I'd like to open it up to questions and answers, and then we can give the floor to Dr. Lee.
Great. Thanks, Steve. If anybody would like to go ahead and ask questions, feel free to chat it into the chat box. I'll give you a couple of minutes to do that. Otherwise, we'll go ahead over to Carole Lee. I'll give you a minute or two to chat those questions in if you have any. Could you explain a bit more about whether staff screen for COIs before asking reviewers to check? Yes.
Yeah, I think, well, so in general, again, we check using that personnel list that's comes in with a lot of the proposal metadata. And then we identify people that are part of the proposal. We actually go through the proposals and make sure that data is accurate to make sure we've captured every person that's associated with the proposal. And then they're obviously on a do not recruit list, so they're never contacted. So that's essentially how the first part of the process works. Yeah. Okay,
I have another question. How effective is reviewer training in general? Literature speaking against it.
Yeah, that's right. That's a good point. There is some data about peer review training in terms of kind of more like journal review. It shows that it's relatively ineffective, or if it is effective, it's only effective for a short term, and then you know, you have to basically reteach it again and again. So I think, yeah, I don't know. We'll have more. I think it depends on what type of reviewer training you're talking about. If you if there's a general kind of understanding across funding agencies as to what type of conflict of interests are significant, it may be that'll increase awareness. But yeah, you're right. More research has to go into what type of training is effective. But we haven't done an inordinate amount of reviewer training other than what has been available on our website and how we interact directly with the reviewers. But there are no modules per se that we typically give people.
So first, I'd like to thank the American Institute of Biological Sciences for inviting me to speak with you. And thanks to Steve for that terrific presentation. Steve's work on conflicts of interest among reviewers is a wonderful example of a more general concern we have about peer review. In general, we worry about how incentives in science can corrupt peer review processes and prevent us from achieving our goals in science. And so what my talk will do is explore this theme a little bit more broadly, to think about incentives in science, how it can corrupt peer review, and what our goals in science are. Next slide. Great. So what are science's goals? Well, in public, things like truth and innovation are valorized, not just by individual scientists, but by journals, granting agencies, decrees by Congress, as well as the Executive Office of the United States. However, in private, individual scientists and scientific institutions seem to thwart the achievement of these goals through biases and peer review. You can change that next slide. Now, truth has taken a hit. In the aggregate, reviewers and journal editors seem to prefer to publish new statistically significant effects. And of course, the disproportionate publication of these kinds of results can lead to false and exaggerated meta-analysis measures. And now, authors, in chase of statistical significance, have increasingly turned towards scientifically questionable as well as fraudulent research practices. Next slide. Now, innovation has also taken a hit. So the perception that grant review is intellectually conservative is held not just by applicants, but also by grant program officers and by granting agencies more generally. Previous surveys have demonstrated that grant applicants report downplaying the more transformative aspects of their applications, and some worry that some scientists forego submitting very innovative projects altogether. Next slide. So on the surface, it looks like peer review is in a state of doublespeak, or at least that's what a stylized reading of the peer review literature might suggest. So how has science gotten into the situation, and what can be done about it? Next slide. Now, what I want to propose is that commensuration bias may be to blame. Commensuration is just the process of converting distinct qualities into a single metric or system of values. So this is a practice that's ubiquitous in our social lives. For example, we assign prices to very different kinds of things. The amount of money you might pay for a washing machine is about the amount of money you might pay for a week's worth of elder care, which is less than what a family of 4 on average would expect to pay for a vacation at Disney World. Now, this process of commensuration is really valuable because it allows us to represent and compare distinct and very different kinds of things. But you can see from these examples that commensuration is also inherently interpretive and too important to be left unaddressed. Next slide, please. Now, an important feature of peer review is that peer review for both journal manuscripts and grant applications involve commensuration practices. So, for example, in the evaluation of journal manuscripts, reviewers at the top 100 science journals are asked to evaluate manuscripts for their novelty, significance, and their methodological soundness. Next slide. At NIH, reviewers are asked to evaluate grant proposals for their significance, innovation, approach, and as well as the investigators' qualifications and institutional resources. Next slide. And at NSF, at NSF's merit review process, reviewers are asked to evaluate applications for intellectual merit, as well as broader impacts, which collectively break down into these sub-criteria: the proposal's potential for transformative research, rationale, the PI's qualifications and institutional resources, as well as the social impact of the project. Next slide, please. Now, one slide behind. Now, what you might have noticed in all of these cases is that in the end, reviewers are asked to provide a score along a single dimension of evaluation after they've evaluated proposals and manuscripts along all of these dimensions. So next slide. So for example, in the case of journal review, reviewers are given an ordinal scale of value that includes ranked options like accept, accept with revisions, revise and resubmit, and reject. Next slide. At NIH, reviewers are asked to score proposals for their overall impact and are given a 9-point scale where 9 is the highest and 9 is the lowest. Sorry, 1 is the highest and 9 is the lowest. Next slide. And at NSF, again, reviewers are given a ranked set of options that include things like excellent, very good, good, fair, or poor. Now, what you can see from these examples is that peer review in these cases, in both journal review and grant review, involve normative and structural features in common. Reviewers are asked to evaluate submissions along multiple dimensions, but in the end are asked to figure out how to weigh those dimensions in their assessments of a submission's overall value. Next slide, please. Now, sociological style of research on peer review demonstrates that not all peer review criteria get equal weight when people convert values for all these different peer review criteria into a proposal or a manuscript's overall value. But more disturbingly, research on fellowship and grant applications has found that individual reviewers can disagree with each other quite a bit about how to weigh these different peer review criteria, even even when they're given identical submissions and given identical instructions. Now, this observation raises some natural questions. Next slide, please. So how is it that scientists weigh peer review criteria in manuscript and grant review? Are there better and worse ways of weighing these criteria when it comes to trying to achieve the goals and aims of science? And how can we change review processes, institutions, and communities to achieve scientific goals more efficiently? These are the questions that I'm going to address in my talk. Next slide, please. Now, in the course of my talk, what I hope to be able to show is that this notion of commensuration bias can do some good work for us. First, it can illuminate how intellectual priorities and individual peer-reviewed judgments can subvert collective goals in science. Second off, I think it helps to animate a less Orwellian view of what's going on in science by showing how the kinds of biases or results we see are the result of individual judgments and structural conditions. And I think that the notion of commensuration bias can be really useful because it helps to identify multiple loci for change. Next slide, please. Okay, so what does commensuration bias look like in the context of manuscript review? Well, recall that at the top science journals, reviewers are asked to evaluate manuscripts for their novelty, their methodological soundness, and their intellectual significance. Now, novelty is important because it prioritizes the discovery of new truths. Methodological soundness is important because it helps us assess what are likely truths by giving us a way of evaluating the reliability of data collection and analysis strategies. And significance is important because it tells us which novel truths are the important ones to report. Next slide, please. Now, if we're worried about trying to preserve the truth-seeking aims of science, then two classes of significant roles, intellectually significant results are important. So replications are important because they're needed to correct and increase confidence in already published results. And null results are really important because if we engage in the disproportionate publication of just statistically significant effects, then this leads to skewed meta-analysis measures later on. Next slide, please. Now, unfortunately, null results are disappearing from the published record in sort of like a really frightening way. So a recent survey of 4,600 papers across the sciences found that 72.2% to 91.5% of published papers report statistically significant rather than null results. They found that publication bias increased by 22% between 1990 and 2007. So this preference to publish statistically significant rather than null results has been getting worse over time. Research in biomedical sciences found that it seems to be authors who are responsible for this kind of pattern. Authors in preemptive anticipation that their null results would get rejected by reviewers and editors seem not to submit these kinds of results, and if they do, take a much longer time to submit them. Finally, research has demonstrated that authors have increasingly adopted questionable research practices as well as fraudulent research practices to craft statistically significant results. And of course, this increases the rate with which we find false positives in the literature. Next slide, please. Now, there's also some research suggesting that replications are also underrepresented in the published literature. So some old surveys suggest that 72% of social science editors say new effects are more important than successful replications. 58% of social science editors say that new effects are more important even than failed replications. The social science reviewers thought replications should take up 10% or less of journal space, and natural science editors published fewer replications than social science editors did. Next slide, please. Now, if reviewers and journal editors prefer to publish significant results, where significance is understood as statistically significant results, then this has the effect downstream of creating an archive of biased data. And as a result, with the archived data that we have in the published record, we can't arrive or create accurate meta-analysis measures. So if we're worried about trying to achieve truth in science, we should think about how it is that we want to rebalance the weighting between this notion of significance and methodological soundness. Next slide. Now, grant review involves a different kind of weighting problem. If grant agencies take a primary goal of their work to be to advance the frontiers of knowledge and foster fundamental creative discoveries, innovative research strategies, and their applications, then it's going to be really important for reviewers and grant program officers to give novelty and innovation sufficient weight in the peer review process. Next slide, please. However, as I mentioned earlier, the overriding mythology or understanding is that grant review is actually quite intellectually conservative and takes methodological soundness or approach scores to be much more important than novelty or innovation. Next slide, please. So, for example, in a recent regression analysis that involved more than 30,000 NIH applications from fiscal year 2010, they found that for every 1.4 change in overall impact score, you see a 1-point change in innovation score, and for every 1-point change in approach score, you'll see a much bigger change in overall impact score. You see a 6.7-point change in overall impact. So you can see on average that reviewers take innovation scores much less seriously in arriving at overall impact scores than they take approach scores. And this suggests a kind of intellectual conservatism. Now, highly innovative projects face special kinds of worries as well. So a survey of reviewers for NIH's Director's Pioneer Award program surveyed reviewers and found that for them, the most innovative projects were the projects that involved methodological risk. And the kind of methodological risk where the applicants were trying to use techniques or equipment that weren't proven yet or were considered very difficult. And so you see there that conceptually, high innovation is tied to methodological riskiness. This kind of result is also found in surveys and interviews done of reviewers at the European Research Council, which found that frontier proposals, which are sort of their most novel proposals, were considered to be methodologically risky and paradigm challenging, whereas excellent research was conceptualized in ways that suggested that they were methodologically rigorous. So again, notions of excellence seem to be conceptually and sort of antithetical to methodological risk. Next slide, please. Okay, so one way to think about commensuration bias is to think about it as the result of lots of decisions made by individuals over lots of layers of hierarchy. And to think about how we might go about debiasing commensuration, I think it's really helpful to think about how these decisions are made at lots of different levels. So what I'll do now is start at the reviewer level. Next slide, please. Now, how can we debias commensuration by making changes at the reviewer level? Well, one thing that we can do is to give reviewers instructions on how to commensurate different peer review criteria. So, for example, there's a fellowship program in the social sciences and humanities in Canada that gives reviewers an algorithm for how to weigh different peer review criteria and arriving at overall scores. Another strategy that we might use at the reviewer level includes redacting certain kinds of peer review criteria to include only the criteria that we think are most important. So, for example, PLOS One and PeerJ, which are open access peer review journals, intentionally don't use intellectual significance as a kind of criterion in peer review because they worry that this prevents the publication of replications and null results. Next slide, please. Now, how can we debias commensuration practices at the managerial level? And here at the managerial level, I include journal editors as well as program officers. Well, one technique that managers can use is to ask peer reviewers to provide scores on individual peer review criteria, and then curate a portfolio of submissions that includes some percentage of submissions that score highly on the kind of criteria that reviewers undervalue. So, for example, a recent report by Lindner and Nakamura suggests that the National Institutes of Health dedicates about 8% of their research funds to funding high-risk, high-reward research. So exactly the kinds of proposals that reviewers might undervalue in their peer review processes. Another strategy that can be used at the managerial level is to have reviewers use less fine-grained scoring systems. The beauty of this strategy is that when you use a less fine-grained scoring system, that creates more ties among competing submissions, which gives managers leeway to use tiebreakers like policy interventions, things like the desire to fund more innovative projects. And so you can see that these tiebreakers can be used by managers to try to round up the applications and manuscripts that they think are underappreciated by reviewers. Next slide, please. Now, at the institutional level, we can do a number of things. One strategy that institutions can use to increase the acceptance of manuscripts and grant applications that don't score as highly on reviewers' preferred criteria is to increase acceptance rates in general. Now, this is an easy thing to do for journals in the age of online publication. For grant agencies, it's a little bit more difficult, but it can be done by accepting more grant applications and allocating fewer grant dollars to each one. And I know that this goes against current trends at both NSF and NIH, but I think it's a consideration worth keeping in mind because there's a cross-agency study done at the funding agencies at Norway that found that as acceptance rates increased at an agency, considerations and weightings of novelty were higher. So I think, so that seems to suggest that increasing acceptance rates really can help de-bias commensuration. Now, another strategy that institutions can use is to create in-house compensatory systems and house those under their brand. So, for example, in the case of journals, Nature has created Nature Communications, again, part of their brand, but it's meant to be a forum for the kinds of papers that aren't maybe as intellectually significant as the kinds of papers that they would print in their journal, in their paper journal. Likewise, at NSF and NIH, you see parallel funding mechanisms that try to fund highly innovative research through their own system. Next slide, please. All right, so another thing we can think about in trying to de-bias commensuration practices is to think about what kinds of new institutions are cropping up to help the state of science. So online journals are cropping up. PLOS ONE is a wonderful example of this kind of journal where they're accepting the kinds of papers that aren't preferred by reviewers because they because that kind of journal takes methodological soundness more seriously than they do intellectual significance, when intellectual significance is understood as statistical significance. Data repositories are also popping up so that people can archive a fuller range of data for reanalysis and meta-analysis. The Center for Open Science can archive and publish a research program's entire life cycle. At crowdfunding sources, crowdfunding sources for money are becoming more popular among scientists. So things like MicroRhiza are becoming more popular for scientists looking for money, as well as philanthropic prizes and funds, which are becoming more popular among scientists when it comes to funding their research. And again, the peer review criteria and the weightings for those criteria vary across these kinds of institutions and may not exist at all for some of these institutions, such as the Center for Open Science. Now, one of the things I want to say is that I've talked a bit about progressive strategies, policies, and institutions that we might adopt in order to de-bias commensuration practices in peer review. I don't have time to evaluate which of these strategies, policies, or institutions might be the best one for us to pursue. But what I do want to say is that any strategy that tries to de-bias commensuration is one that is also going to have to change the culture of what is valued in scientific evaluation. And so we have to think directly about how to change the culture and incentive structure in science, especially in disciplines that are hyper-competitive and have very conservative practices surrounding reputation building. Okay, next slide, please. Okay, so in the time that I have left, I want to say just a little bit about how commensuration practices might be impacted by social biases, so by the perceived gender or race of the applicant or author. Now, in social psychology, they found that when you give subjects job applications and ask them to evaluate those job applications for multiple criteria, those subjects will prioritize whatever criterion favors the white or male candidate rather than the minority or female candidate. So, for example, Norton and his colleagues asked subjects to evaluate job applications for a construction management position and asked them to evaluate them for education and experience. Subjects prioritized education when that favored the male candidate and prioritized experience when that gave preference to the male candidate. Now, in that kind of case, what you can see is that the practice of weighing more heavily whatever criterion prefers the socially desired candidate is also a practice that will give higher overall scores to the socially preferred candidate. And indeed, in the Norton and al. Study, what they found was that subjects valued the male candidate as being more hireable even than an identical female candidate. Next slide, please. And so a natural prediction that you might make on the basis of this empirical research is that you should expect commensuration bias against women and minorities in peer-reviewed practices. And I think that commensuration bias can be measured when white or male researchers receive higher overall scores than minority or female researchers, even though they have received identical scores on individual peer-reviewed criteria. Now, unfortunately, I don't have any results or data to share with you at this point. Right now, we're still hoping to get some data to try to do this kind of research. But what I'll do in the time I have left is flesh out the idea that my collaborator, Elena Arosheva, and I developed for the NIH contest on new methods to detect bias in peer review, just to give you a sense of how this could go. And we were very honored to have received first prize for most creative idea. Next slide, please. Okay, so in 2011, Donna Ginther and her research team found that when looking at NIH grant applications for fiscal years 2000 to 2006, it looks like Black investigators are 10.4% less likely to be funded than their white peers, and Asian investigators are 4.2% less likely to be funded than their white peers, even after controlling for their productivity, citations, education, employer type, as well as previous NIH training grants and review experience. Next slide, please. Now, one of the things that was really interesting about this result was that they found that applications with good scores were more likely to be funded regardless of race or ethnicity. And what this seems to suggest is that in order to understand racial discrepancies in funding, we have to understand racial discrepancies in scores. Now, to think about this, remember that NIH has a two-step process or a two-round process. In the first round, reviewers and discussants are asked to evaluate grant proposals along 5 sub-criteria and then provide a preliminary impact score, which is sort of the overall score. About half of applications make it from the first round to the second round, and which applications make it to the second round is determined by these preliminary impact scores. Now, Ginther and her colleagues found that Black and Asian investigators were less likely to make it to that second round of review. Next slide, please. Now, in the second round of review, which happens after the scientific review group meets to talk about the applications, reviewers and discussants are again asked to evaluate proposals for this 5 sub-criteria and then provide an overall impact score. The overall impact scores are aggregated, and then decisions about which applications receive funding are determined by looking at those aggregated impact scores and looking at the overall the pay line for that year. If an application receives overall scores that are above the pay line for that year, then in general, those applications receive funding. And again, Ginther and her colleagues found that Black and Asian investigators were less likely to get scores that go above that pay line. Next slide, please. Now, one of the things that's interesting about NIH's process is that they ask reviewers to weigh the different subcriteria as they see fit, and they note that an application need not be strong in all categories to be judged likely to have major scientific impact. So how reviewers decide to weigh the different subcriteria in these two phases of review can make a big difference in whether or not an application makes it through both phases of review. Next slide, please. Now, I want to note that this kind of way of studying for social bias is different from the kinds of studies that you're probably familiar with. So you're probably familiar with the kinds of studies that try to show that reviewers are biased when they score individual criteria. So Winners and Wolves have the famous but recently contested finding that women have to be more productive in order to be deemed as competent as their male colleagues. In contrast, this kind of study wants to focus not on social biases in how we score individual criteria, but how people unconsciously combine those scores into overall scores. Next slide, please. Now, the reason why I think that studying this kind of bias is important is because it gets at certain kinds of concerns that people have, and it allows us to study those concerns in an analytical way. So Michelle Lamont, who's a sociologist at Harvard, recently published a book on her observations of panel discussions for high prestige interdisciplinary fellowships. And what she found was that funding decisions often depended on very idiosyncratic processes of salience. So panelists would talk, certain aspects of a proposal would become salient to panelists, and then decisions about whether to fund that proposal or not depended on which aspects sort of made it to the top of people's attentions. Now, a couple of senior African-American panelists voiced concern that race might drive these salience processes. And this is from the perspective of those two panelists and from the perspective of Lamont, there wasn't a systematic way of trying to study whether this is the case. But with the right kind of data set, this is precisely what we could study in an analytical way. We could study whether or not race drives salience processes and looking at which peer review criteria becomes salient for peer reviewers in their overall scores. Next slide, please. Next slide, please. Okay. As I mentioned before, we don't have data in hand for doing this kind of study. But if you have any ideas on journals, conferences, or granting mechanisms that might be open to studying this kind of bias, please do send me an email. I'd be really happy to talk to you about that. Okay, so I talked your ears off at this point, and I'll go ahead and wrap up. So merit review criteria are in place to try to ensure unbiased peer review and to try to ensure that science achieves its overall aims. Next slide, please. But what's really interesting about peer review criteria is that our peer review criteria aren't sufficiently characterized to determine how they're interpreted and applied in practice. As a result, there's a lot of flexibility in how reviewers apply peer review criteria from case to case. And what I spoke about in this talk is how flexibility and the commensuration of those different peer review criteria can lead to problematic outcomes. In the aggregate, they can subvert our efforts to achieve true claims, innovative work, and possibly fair processes and outcomes. Throughout the talk, I hope that I've convinced you that this notion of commensuration bias can help us identify progressive strategies for trying to de-bias processes and outcomes at multiple stages and levels of hierarchy in our peer review processes. Thank you.
Thank you, Carole. I have a couple questions people have already been asking, so I'll go ahead and send those out to you now. Let me see what I have. Hold on, let me find them. Let me just track it down since here we go. So I asked about, in your slide number 6, whether or not you feel that a research question that goes counter to the dominant paradigm might be suppressed as a bias.
Yeah, so there is a good deal of research on conservatism of that sort. So there's a well-established finding in social psychology suggesting that we are all prone to confirmation bias. So when we're faced with a kind of evidence or a hypothesis that runs counter to something we already believe, we tend to discount it and require a higher standard of evidence in order to accept that hypothesis. And this kind of finding has been replicated in some work that has tried to see whether reviewers who hold the opposite view than what a paper argues holds a higher standard of evidence in order to accept that paper. And indeed, that seems to be the case. If you're interested in references for those studies, please send me an email. I'm happy to send those to you.
Great, thanks. Here's another question I have is, have you considered what the implications of your important work might be? Sorry, people keep asking and this keeps moving. What your implications of your important work might be for work funded by the private sector to infiltrate the scientific literature for the production of junk science. What standard does this set for scientists funded with public funds?
Great. So one of the things that's interesting about publicly funded research is that it's vulnerable to a kind of political scrutiny that privately funded research is not. So, of course, NIH and NSF are routinely under the scrutiny of Congress people and presidential candidates who want to find a way of looking tough about federal funding, and every year have to give reports on how well they're doing in terms of funding research that gets published and is highly cited, et cetera. And so there might be institutionally a kind of need politically to try to fund methodologically safe work, or at least a lot of it, while reserving some amount for innovative, high-risk, high-reward research. In contrast, when you think about private sources of funding, they aren't subject to those kinds of pressures, and so can create peer review criteria that make that are much more risk-seeking in their efforts. So the Center for Open Science, which has been sort of a really innovative institution in science, is funded by a very generous private source. And I think that the tie between innovation and type of funding there might not be an accident. I hope that answers the question. If not, please email me and I'm happy to answer what you actually intended to ask.
Great, thanks. Just another question. Carole, does a reviewer's position on the democracy dimension create bias? For example, at one end, reviewers who evaluate a proposal based on beliefs about the proposal's research field closely held by themselves versus reviewers who consider what the larger population of scientists, their peers, generally believe about the research field that the proposal fits in.
I see. So this is, I'm taking this question to be a question about how reviewers evaluate proposals and whether they evaluate them from the perspective of themselves as a particular researcher located in a particular intellectual place in the community, rather than from the perspective of the entire community as a whole. I'm not sure if survey research has demonstrated whether or not researchers use one sort of social location versus the other to evaluate manuscripts. But I do know that from Ware and Monkman's survey work in 2008, that the most common reason for researchers to decline reviewing something is because they feel as though they aren't an expert in that topic. And so it may be that reviewers only accept submissions or take themselves to be credible in evaluating the submissions for which they have direct expertise. And again, if I didn't answer the question you intended to ask, please email me.
Okay, I think we have one more time for one more question. We're almost at 3 o'clock. This is for Carole. Carole, have you had the opportunity to look at what the impact is of increasing the funding rate of grant applications in terms of grant outputs, i.e., does a lower amount of funding reduce the number of results in publications?
Oh, that's interesting. So I'm not aware of work on funding rates and productivity measured in terms of the number of papers published or the number of citations created. But I will say, and if anyone knows of any work, I'd love to hear about it. But I will say that it's not clear to me that the number of publications or the number of citations should always be the metric that we use when assessing how successful a grant proposal has been. So, for example, the kinds of work that tend to be cited more are not the policy-oriented, applied work that might be most relevant in informing policy. But that kind of work might precisely be the kinds of work that are most important in terms of other sort of grant agency goals, such as improving human health. So I'm imagining cases where, applied work on minority populations isn't cited by the mainstream medical researchers, but that applied work might have a huge impact on the more practical concern we have, which might have to do with how to implement, for example, a certain kinds of scientific intervention to improve health outcomes for minorities. So I think that there are a lot of questions left to explore, and trying to figure out the best methods and concepts to use to improve the literature and the process is a really important venture.
I would just mention real quick, we actually published something in 2014 where we actually did see a relationship between kind of the overall grant output in terms of number of publications and citations per grant and the funding rate. So in other words, for the same program over a period of 10 years, as they reduced the budget per application or per project and increased the number of projects they could fund, they actually, as a total portfolio, increased their overall output. It may not have increased per grant, but in the aggregate, there were hits that were high citation level outputs. So their portfolio was improved by funding more ideas with less budget. But
great, thanks for that, Steve.
Sure.
We are at a little over after 3, so I just wanted to go ahead and hand it over to you, Stephen, if you want to go ahead and say any final thoughts.
Sure. Just thank you very much for signing in. I'm sorry we didn't get to everything. I realize it's a bit hard to congeal two talks into one in an hour and then somehow throw questions and answers in there. But again, both of our emails are up there, and I can send them out to the group if that's needed. But please feel free to email me any questions. I noticed there was something about, there were a couple I think I missed. I apologize. I think there was a bit of a technical glitch in the middle, so I kind of lost my concentration. But as I say, please feel free to email either myself or Carole. I'd be happy to respond. And I look forward to potentially talking to you again at one of these future webinars, which I think the next one about evaluating